So I titled this video Honors Algebra, but really algebra is just algebra, right? So the questions in today's video are questions that all of us who graduated from high school should be able to answer. And I want you guys to know that I believe in you. So in today's video, we're going to answer 3 algebra questions together. And these questions should be good for anyone who's studying for a variety of different exams, whether it's the PCAT, GRE, SAT, or one of those other standardized exams. Or if you're just someone who's trying to brush up on your algebra skills, or if you're a parent trying to teach your kids. This video will help us all improve together. So let's dive into it. Question number 1. So question number 1 says, a function f of x is to be converted to a function g of x. The function f of x will be shifted to the left by 3 units, then stretched vertically by a factor of 2, and then shifted downwards by 8 units. Which of the following correctly defines g of x in terms of f of x? So this is a question about function transformations. So we should definitely know how to shift a function up or down, side to side, or how to stretch a function horizontally or vertically. These are definitely the type of math skills that you want to make sure that you have. So let's go ahead and analyze this question together. So we have a function f of x, and the first thing we're going to do is shift this function to the left by 3 units. So how do we shift the function to the left? We have to remember how a function is plotted. The independent variable is along the horizontal axis, or called the x-axis, and the dependent variable is along the vertical axis, or called the y-axis, right? If we're going to shift this function left or right, that means we're going to be shifting this function along the horizontal axis. And which variable controls the horizontal axis? That's the independent variable, which is the variable x. The function is called f of x. F, which is the dependent variable, is a function of x, the independent variable. So if we're going to shift the function left or right, we're going to change the independent variable. How do we shift that variable to the left? Well, the first thing you might think is we just subtract from it. We want to move to the left, so we take the variable x and subtract from it so we can move to the left. But be careful there, because that's incorrect. You don't subtract from the variable if you're trying to shift to the left. And an easy way to see that is to focus on the origin. So focus on the 0. So in the original function, f of x, the independent variable took on the value of 0 when x would be equal to 0. So the independent variable would be equal to 0 when x would be equal to 0. But what would happen as we shift the function over to the left? If we shift the function over to the left, then 0 would occur where -3 initially was. 0 would move 3 units over to the left. So your initial 0 is going to end up at -3. That means that if we want to shift the function over to the left, we want f of 0 to occur when x equals -3. Therefore, what we want to do to the independent variable is to add to the independent variable. So now, instead of having the function f of x, we change it to the function f of x plus 3. Because if you take a look at x plus 3 equals 0 if x equals -3, which is exactly what would occur if you shift the function over to the left. So that's step number 1, to add 3 to the independent variable. And then we were asked to stretch the function vertically by a factor of 2. The vertical axis is the dependent variable. F is the dependent variable. So what we want to do is we want to stretch f by a factor of 2, which means we want to multiply f by 2. And then the last thing we want to do is we want to take the function and shift it up by 8 units. So we want to add 8 units to our function. So we have 2 times f of x plus 3 plus 8. So the correct answer will be answer choice D. Okay, 2 times f of x plus 3 plus 8. So hopefully that makes sense. Now let's go on to question number 2. Okay, question number 2 says, what is the domain of the function f of x equals 6x divided by the square root of 2x squared plus 5x plus 3? Okay, so this is a domain question. What does that mean? The domain of a function is the list of all the numbers of the independent variable where the function f is well defined. The domain is the list of numbers that the dependent variable f allows the independent variable x to have. When it comes to determining what values x is not allowed to take, we just need to look at the function and determine the values that would make the function be not well defined. And key problem areas that makes a function not well defined is having 0 in the denominator or having negatives in square roots. So in this question, we have a denominator and we have a square root. So those are 2 areas that we want to look out for to exclude certain numbers from our domain. So let's go ahead and look for zeros in the denominator. What would cause a 0 to occur in the denominator? That would be if the quadratic equation inside the square root takes on the value of 0. So let's look for the values of x that would cause that to happen. So let's go ahead and isolate the polynomial in the square root of the denominator and go ahead and factor it. And when it comes to factoring polynomials, I've already done a video on that, so go ahead and check that out if you haven't done so already, to make sure that you know how to factor these quadratic equations. We're going to skip that step and go ahead and directly factor this polynomial. And when we go ahead and factor this polynomial, we get x plus 1 times 2x plus 3. It's easy to find the zeros of this polynomial. That would be if x plus 1 equals 0, or if 2x plus 3 equals 0. If x plus 1 equals 0, then x will be equal to negative 1. And if 2x plus 3 equals 0, x will be equal to negative 3 over 2. So these are the two areas that will cause a 0 to occur in our denominator. And these will be excluded from our domain. But we also have to remember that this polynomial is also inside a square root. And remember, a negative square root is not a real number. It's an imaginary number. So negative square roots are also not allowed to be in our domain. So we need to look for where this polynomial would be negative. And of course, this polynomial is a quadratic equation. It is a parabola, and it is an upward parabola, which means that this function is negative between the values of negative 3/2 and negative 1. So we also have to exclude the region from our domain. And which answer choice does that? That would be answer choice B. Answer choice B says negative infinity to negative 3 over 2, and then it jumps to negative 1 to infinity, which means that the region between negative 3/2 and negative 1 is excluded. So the correct answer is answer choice B. Now let's go on to question number 3. Question number 3 says, find the vertical asymptotes VA and horizontal asymptotes HA of the function y of x equals 3x to the 3 plus 2x minus 1 divided by x to the 3 plus 2x squared minus 4x minus 8. Okay, so it's a more complicated function, but it's still a rational function, and it's still something that we know how to deal with, right? But in this case, we're being asked to find vertical and horizontal asymptotes. A vertical asymptote is defined as a vertical line x equals a, where the limit as x approaches a of the function y of x is equal to plus or minus infinity. So when it comes to finding the vertical asymptotes, we just need to find the values of x that would cause the function to take on the value of plus or minus infinity. And the way that you get infinity is by having zeros in your denominator. Zeros in the denominator are going to cause vertical asymptotes to occur. So let's go ahead and look for zeros in the denominator. The polynomial in the denominator is x to the 3 plus 2x squared minus 4x minus 8. So once again, let's go ahead and factor this polynomial. So we're going to take x to the 3 plus 2x squared and factor that term. And when we factor that, we pull out an x squared, and we get x squared times x plus 2. And now we're going to factor the second half of the polynomial, which is the minus 4x minus 8. And we can factor that half by factoring out a minus 4, and we get minus 4 times x plus 2. We have a common factor of x plus 2. So we can factor out an x plus 2, and we get x plus 2 times x squared minus 4. And we can factor the polynomial x squared minus 4 as x plus 2 times x minus 2. And this is going to leave us with x plus 2 squared times x minus 2. And therefore, zeros in the denominator will occur if x equals minus 2 or if x equals plus 2. And these will be our vertical asymptotes. So now that we found our vertical asymptotes, let's go ahead and find our horizontal asymptotes. Horizontal asymptotes are very similar to vertical asymptotes. They're just the opposite, right? And the opposite is that as x goes to plus or minus infinity, y approaches a finite number called a. So to find our horizontal asymptote, we just need to take our function y of x and set the limit as x goes to plus or minus infinity and see if y approaches a finite value. We're going to take the limit as x goes to plus or minus infinity of the function 3x cubed plus 2x minus 1 divided by x to the 3 plus 2x squared minus 4x minus 8. In the numerator and in the denominator, we have polynomials. And as x becomes a big number, the part of the polynomial that would dominate will be the polynomial of the highest term. In the numerator, the highest term is 3x to the 3. And in the denominator, the highest term is x to the 3. And we can go ahead and cancel the x to the 3 in the numerator and the x to the 3 in the denominator, and we get 3. Okay? So, as x goes to plus or minus infinity, y approaches the value of 3. And that is the horizontal asymptote. So, the correct answer is going to be answer choice C. Y equals 3 is the horizontal asymptote. All right, so there you have it. Let me know if that was helpful. If you have any questions, leave it in the comment section below. Let me know if you enjoyed the video. Like, share, and subscribe. And as always, I'll see you guys in the next one. Bye-bye.